Welcome to our next video. This one is on calculating the mean. Another name for mean is finding the average. But here's your learning target, 6SP5. Summarize and describe distributions by giving quantitative measures of the center. That's a whole mouthful of what we're going to be talking about. Basically, we're going to be finding the middle of our data, the mean. And I can calculate the mean of a set of data or work backwards from the mean to find a missing data value.
So let's get our vocabulary word down. Mean is the sum of the data divided by the number of pieces of data. So we're going to add up all the numbers in whatever we get, a graph, a table, and then we're going to divide by the number of pieces of data that we have. It is the balance point for the data set. If you think about a pan balance, that's what they call them in science.
Yeah, kind of balancing your highs and your lows.
You're balancing your highs and your lows so that your balance beam is completely even. All right, it's been a while since you guys have looked at a pictograph. This example shows you the number of members on 4 different swim teams. It is so important to look at that key to make sure that each
the world's worst star ever.
Is one swimmer in this graph. We need to figure out how many are on each swim team so that we can add them up and divide. So Mr. McKenzie is counting now. What do we got? 9?
So that's a 9. We have 1, 2, 5, 6, 7, 8, 9, 10, 11. This next one is 3 less than my 9 up here, so it's a 6. And this one's 4 more than 6, so that gives me a 10. So first we had to figure out what numbers do we have. Our rule up here is we're going to find the sum of the data, meaning add them all up. 9 plus 11 plus 6 plus 10. And you are allowed to use a calculator with this one.
On this calculator, make sure
so we should get what, 36?
Hit equals. You get 36 for the sum. Now you have to divide by the number of pieces of data. So you have
1, 2, 3, 4 pieces of data. So we're going to divide by 4. Here's the rule. You are allowed to use a calculator as long as we see all of these steps.
Your addition statement and what you're dividing by.
What did you add up? What did you get? And then what did you divide by?
That 36 sum is important to write down. 36 divided by 4 would be 9. The average would be 9. Thanks for the label. That's
9 swimmers. It started looking like swim, and then
it
got ugly.
Next thing we have a frequency table. So there's no graph, just a table. And we're going to add up the numbers for each month of snowfall and divide by 5 months.
So we're going to add each one of these up. So yes, you have to show us this each time. We need to know what numbers you're using so we can figure out how you were working through the problem.
Before you complain, it's easier than actually adding them up. 80.
Adds up to be 80.
Yes.
There is 1, 2, 3, 4, 5 data values. So we're going to divide by 5.
Which is an average of 16 inches of snow. No, thank you.
That's more than we got the whole year, let alone in a month.
Goodness. Bring on spring. All right, jacket prices. We've got a bar graph. Everything's spaced so nicely.
Luckily, the graph is nicely done for you, so they told you what each value is. You didn't have to read it off of the scale there. So we want to add them up. 22 plus 25 plus 28 plus 9 plus 21.
Equals 105. We have A, B, C, D, E, which is 5 letters of the alphabet, 5 bars in our graph. So 105 divided by 5 would be an even $21 for each jacket.
Now, a good thing to do is when you're looking at your numbers, notice we got a whole bunch of them in the 20s and then one little bit lower one. Our mean should be somewhere in between those numbers. The whole point of a mean is finding the balance point or the average. So if you get 30-something or 40-something, you know you've messed something up in your calculation. You should be expecting a number in between your numbers here in the 20s somewhere.
All right, we're going to have you do these 2 on your own. We just really need to make sure that you look at your keys. In this pictograph, the bicycle is 2 bicycles. So for the Smiths, it's not 2, it's 4, because each bicycle is worth 2. So go ahead and add them up, divide by the number of pieces in your data, and then tell us the mean. Press pause. Okay, here we go. We have 2, 4, 6, 8, 10.
It's going to be 10, 4.
18 divided by 3 is
3 values.
6.
So we end up with 6 bikes for an average. Here, notice the checker piece is equal to 4. So we have multiply everything times 4. So we have 24. 4. Here's 8. So that would be 32. And then 5 times 4 is 20. So 24 plus 4 plus 32 plus 20 is...
80 divided by 4 is 20.
Did you really do 80 divided by 4 in your calculator?
I guess I did. I just do it so automatically. 20 checker pieces.
Which makes sense. It's kind of in between the low and the high of our numbers here.
Yeah, that low is bringing down the high. All right.
Here is where we're really going to put it to use. Instead of just being able to plug in some numbers and do some calculator work, now we're going to have to put the mean to use to find something we're missing. So this one says Jamila babysat 9 times. So we should have 9 numbers. She earned 15, 20, 10, 12, 20, 16, 80, and $18 for 8 nights of babysitting. We want to know how much did she earn the 9th time. So we're missing that piece of information in order to get a mean of 24.
So Mr. McKenzie is going to set this problem up. He's going to write down what he knows. So 15 plus 20 plus 10 plus 12 plus 20 plus 16 plus 80 plus 18. And then he's going to put a question mark for that 9th number. We don't know what it is. He could use a variable, x, n, whatever you want.
We know our variables now.
Okay, and he's going to put divide by 9 because it says 9 times. And he's going to set it equal to 24 because that's the mean of the data set. So we need to add up what we know so far. We have something plus x, but we need to go ahead and add up the 8 numbers that we do know.
Think of some of the problems we just got done with in geometry, where we would do some of the work on one side of the equation when we're finding the area of a triangle or whatever it is. Same thing here. Do the math that you can do.
So that's 191.
So this becomes 191, so I'm going to rewrite it.
X
plus x, and then it's going to be divided by 9.
Is equal to 24. Now, the problem is that...
Now, we try to solve it. We need to get rid of that divided by 9. So think of it kind of like an equation.
So undo division, we multiply.
So we're going to multiply both sides times 9. We're going to undo that dividing.
Which is 191 plus x is equal to 216. So how do we undo addition? By subtraction. So 216 minus 191 gives us x is equal to 25. And we need to make sure that that makes sense. 191 plus 25 divided by 191 plus 25 is 216 divided by 9. We do get 24, so we've checked our work.
Okay. Let's do one more of those because we know these can be a little bit complicated.
So we're going to add up what we know first and make sure we put a variable in there as well.
Now, I've done this kind of problem 1,000 times myself. When I was in school, I always wanted to kind of figure out what did I need to do in that last test to keep the grade I wanted in class. This one said Isabel earned a 78%, an 89, a 92, an 85 on her first 4 tests. If she wants to end the semester with an average of an 88, a B+, what does she need to get on her 5th test? So again,
78
we're going to add up the pieces we know.
89 plus 92 plus 85 plus x divided by 5 is going to give us a mean average of an 88%. So we know
so we're going to do the little bit that we can do.
So those numbers are 344 plus x
plus some number when I divide it by 5 gives me 88. This is where we start to work backwards like an equation.
So we're going to undo the division
they divided,
with multiplication.
So we're going to multiply times 5. So I'm left with 344 plus x is equal to
440.
440. Now we want to get x by itself. We want to undo the addition, so we're going to subtract away the 344.
344. You have 334.
344.
So x is going to be equal to 96. And we need to make sure our answer is actually a percentage that would make sense on the test. And 96 is pretty reasonable. So she'd have to make very few mistakes on that 5th test to get herself an 88.
So look at her score, 96. If she wanted an average of an 88, she got below an 88 here. She got below an 88. This one's just a little above. And then one score that's above. So she needed another score above her 88 to kind of balance out those lower scores. So getting a 96 in this case would make sense. All right, have a good day. We'll see you tomorrow.